Anant Shinde from Sukhakarta Electromech Engineer Private Limited. Mr. Anant Shinde is the director of Sukhakarta Electromech. He is an experienced design specialist with a demonstrated history of working in the research industry. Mr. Anant is skilled in computer-aided design, computational fluid dynamics, product design and development and research. He is a strong community and social service professional with a Master's of Engineering focused in product design and development. Mr. Anant will talk about electrical safety for construction. So let's welcome Mr. Anant.
Electrical regulations in electrical, lots of Indian standards to regulate the electricity. Second is a subpart of CAT 29 CFR 1926, and this is a part 1 safety requirement for installing using equipment. Approval of electrical components, examination of installation, use of electrical equipment, gardening of electric equipment, overcurrent protection, and grounding of equipment. These are the part of safety requirements for installing using equipment. Second part of it is safety related work practice. First is the protection of employees, passageway and open spaces, lockout and tagging cycle. Second part is the safety related work practices. Second is the protection of employees, passageway and open spaces, lockout, tagging of cycle. Third part of the electrical regulation is the safety related maintenance and environmental consideration. Protection of wiring components, environmental determination of the equipment. This is the third part of safety related maintenance and environmental consideration. Fourth is the safety requirement for special equipment. First is the batteries and battery charging. Second is the PPE, personal protective equipment. And third is the emergency eye wash station. How to electricity work? The current flow to the generating source through the conductor to the load. Complete a circuit are needed. This is a simple circuit electrical electron flow. First is the positive source and second is the negative. The flow is the left to right and load. This is the electricity work this like way. Third is a normal route 3 is conductor. Shock occur when the body become the part of the electrical circuit. This is the Ohm's law of electrical equal to I current, E voltage and R is the resistance. Second is the human resistance of the body area. For dry skin 60 lakhs ohms, wet skin 1000 ohms, internal organs 400 to 600 ohms, eye to earth is 100 ohms. These are the formula for facilities at the voltage. Electrical shock occurs when a current enters in the body, the point 1 to exit another point. Shock occurs when a body would touch both wire of the electrical circuit, one wire of energized circuit and the other is ground. Metallic part that is a hot. When electrical current is go through the body, one is one point to another point, and when is the metallic current, the metallic part will be hot. Electrical servocity of shock depend on the amount of current, path of the current, amount of time of exposure. This is the shock. Effect range from the triangle to the quadratic arrest serve the burn and profitable death. Typical household current of 15 amperes can be causes of death. In our household, is a 15 ampere socket. It is when the human touch the socket, it is a death of the causes of death. Electricity psychological effect for 0.001 ampere is a barely felt. 0.15 ampere, let's go to the threshold. 0.20 ampere is a muscular paralysis. 0.1 ampere is a ventricular fibrillation. 1.2 is a 100 watt light bulb. 15 ampere common household tools. Effect of the current 1 to 8 milliampere is shock, not painful. 8 to 15 milliampere is a pain. 15 to 20 milliampere is a muscular constriction. 20 to 100 milliampere is serve pain and paralysis to breathing muscle. 100 to 1000 milliampere is a verticular fibrillation, usually the causes of death. And greater than 1000 milliampere is a heart stop. It's a grounding. When you are taking some type of socket to protect you from electrical shock, safeguards against the fire, protect the electrical equipment from the damages. Second is a two type of grounding includes service or system ground or equipment ground. Circuit protective devices is at a construction site. The most common electrical hazard is the ground fault electrical shock. In a construction site, OSHA required either ground fault electrical intercept or assure the grounding conductor of program. It is meaning that to one earthing is proper The shock, it can be hazardous, no hazardous from the shock. Second is a circuit protective device. Circuit protective devices include the fuse and circuit breaker. Protect the conductor and equipment. Second is the limit and shut off the current. Ground fault circuit interferes, a fast acting circuit breaker that senses the small imbalances in the circuit caused by current leakage to the ground. This is the one type of the circuit, hot and neutral, is a current flow through this circuit. Is a polarity. The hand lamp reverse polarity. This is the electrical line diagram. Some is the one a transformer. Say a hot is the current is flow. Equipment, there is the equipment plug, and current is flow through this line and charge the bulb, and bulb will be glow. And after that, switch off the position. This is the current is reverse position. As like our body. Assure the equipment grounding conductor program. If the GFCI are not used, employer must have scheduled and recorded assure equipment grounding or conductor program. Assure equipment grounding conductor program. It is all cord set detectable that are not part of the permanent wiring structure. Equipment conducted by cord and plug. Third is the equipment must be usually inspected for damages or effect before each day to use. Second is the test must be perfected before the first use. New equipment after suspended damages to equipment, and at 3-month interval continuity test, grounding conductor test. Second is the lockout tagging. Electrical equipment deactivated for the repair must be locked out and tag out at the point where to energize. Protect maintenance worker, warm other and other being the performer. Only person who lock tag the equipment can turn it back on. Before equipment is energized, the qualified person must be conduct test and visual inspection. Each lock tag must be removed by person who applied it. When you are doing the work for electrical, to lock out and tag out. But who's the lock? It must be responsible person to lock out and tag out. Second is if employee is absent, the lock and tag can be removed by the qualified person if the employee who can apply the lock and has left the premises. If usually determine that all employees are clear of the circuit and equipment. Grounding requirements, any live part of electrical equipment operating the 50 volt or more must be grounded to avoid the accidental contact. Entrance to area with live electrical part must be marked with warning sign. This is the danger sign, high voltage authorized person only. This sign must be where doing the electrical work, where is the very high risky hazardous area. Sign should be prohibited entrance exit by the qualified person. Insulation. Check the equipment daily for insulation breakout. These are the insulation breakout. Check for exposed wire, broke down wire, insulated and extension of the cord. This type of in electrical hazardous, very accidental incident. Insulation. Use non-conducting mats, sealed barriers when necessary. Use non-conducting coating on the hand tool. You are using some hand tool, it must be barriers of the hand tool. Personal protective equipment. Employee must provide electrical protective equipment to employee who work near the electrical hazard. Use the appropriate equipment for hazard, including helmets, eye and face protection, gloves and sleeves, aprons, and protective footwear. Thank you.